In this video, you'll learn about what's the fundamentals of the green infrastructure design. And when I say design to improve both water quantity or availability of the water quantity, also the treatments of stormwater for water quality benefits. So as you can see, the green infrastructures, as I said, is always about restoring the hydrological functions similar to the pre-developments of urbanizations or urban areas. How they do that? By increasing infiltrations or retaining the water in some locations. So let's look at the how they do that based on different aspect of it. So again, these are the four functions. First is store water. So that means it's related to size. If the green infrastructure size is much bigger, that means it can retain more water and limit the intensity of flood. So this is related to size. So bigger the size of green infrastructures, the greater the benefit for storage water. In this case, for instance, a pond. The bigger the pond, the more water it can captures. The second function is infiltrations. Infiltrations means it is a recharge to groundwater. So that means we have more water in futures and to supply that water for groundwater. So that means the green infrastructure should have a process where it can increase infiltrations. That is related to the media, or that's related to the soil or the amendments that is used there. So we control that by controlling the hydraulic conductivity or the K of the media. Third one is to remove pollutants. Pollutant can be removed many different ways. We learned that throughout the class. The first removal process, just by holding the water, a lot of pollutants can be removed by exposure to sunlight, or sometimes it's just by settling of solid. So just by keeping water in one location, you remove by default some pollutants. Infiltrations can remove also pollutant, because a lot of pollutants will not pass through the soil or the filter media. They will bind to the media that is there, so that can be used to control the pollutant removal. And so once we achieve all those three, that can, based on the degree of these three functions, that will determine what's the reuse, or whether we can reuse them or we can just discharge them to surface water by limiting the pollutions. So as I said, there are two aspects of it. One is the water quantity and water quality. Let's look at the fundamentals of water quality. Water quantity. Again, water quantity is all about storage, amount of water that you can store. So V is the volume of water that can be stored in green infrastructures, or we can be retained, is a function of how much water that comes in and how much water that's leaving the systems. So for instance, here, if you have a flow rate Q1, that's Q in was coming in, and there is a precipitation or evapotranspirations, and this is the area of the green infrastructures, and then this is Q out, and this is Q infiltrations. Then that means you can use this concept to calculate how much water you have storage in the locations. So change in water storage in the locations would be, in this case, what is coming in is just the infiltrations. You can write this as a precipitations. Precipitation is the amount of water that falls directly on the green infrastructures. Precipitation is basically inch per hour, so it's not a volume flow. So you have to multiply to the area of the green infrastructures. So that's the amount of flow coming in. How much water coming out? Going out is one is evapotranspirations. That's again evapotranspiration ET combinedly, and that is also a surface process where the water evaporates. So that's related to area. So you have to multiply area, and then water that leave the system as runoff, that's Q out, and then also Q infiltrations. So this, if you account for all those things, you will be able to calculate how much water volumes you capture at certain days or years or months. So this is just an example to show that how you can use these equations to calculate the volumes, and we will use that time to time. What about the amount of pollutant it captures or remove from the runoff? In this case, pollutants come in water, so that means we have to understand how that water volumes is related to pollutant mass. Because most of the pollutants in water, so you have to remember the concentration of pollutants is basically mass of pollutants uh, by volume of water. So that means mass. So in this case, we are just looking for mass of pollutants that's being captured. So that means mass is concentration time volume. When you look at dm by dt, that will be d by dt c v, concentration time volume. So when the concentration is constant throughout the time, so you can put that c and then dv by dt. That's basically will say that c volume change in time is flow rate, so c times q. So this is basically amount of water that comes, amount of pollutants come to the system as if through the flow rates. So this is why this is the q times c in, basically mass of pollutants coming in inflow, and this is basically mass of pollutants leaving the system as outflow, because there is a flow rate terms and then the concentration term. And then some of the pollutants are removed in green infrastructure because of imperfections, settling, or degradations. So all those things can be connected here. So here dm by dt is related to amount of pollutant removed because of, you can say, settling, adsorptions, or absorptions, or attachments. You can say degradations. There are all the different processes that could remove the pollutants. So when you account for all those things, that will determine how much mass of pollutants are removed, or how much pollutant is there in the water in that system. So this could be amount of pollutants removed in the systems, in the system, removed or collected in the systems, and this could be also, for instance, if you have a pond, detention pond, or for instance, another location like wetland, you can calculate what is the concentration of pollutant in that wetland as a function of what's coming in, coming out, and what's being degraded. So these are the different functions we can use to calculate estimate the amount of pollutants removed. So we will use that in class in several lectures.